Welcome back to this tutorial series, and in today's video we're going to be finishing up implementing our Newton's method with our calculator. So in the last video we actually finished up implementing it all, but we did not test it at all. So here we're going to test our input. Let's say x squared minus 4. This should have the roots at -2 and 2. We're going to type in none for this example. Our tolerance would be 1e to the -12, bisection value of -5 and 5. So here we're having a string. Okay, I see. So when we input our values, we need to convert these to floats, simply because we do not want to pass in the strings to our functions. So this should fix everything up. Convert all these inputs to floats. So we're going to type in our function, type in none again for this example, 1e to the -12, -5 for our bisection, excuse me, typed in b instead of 5. Type in -5 and 5. So here we have it, maximum iterations. We have a function required to change the signs over the given interval. So if we take -5 and we square it, we get 25. 25 minus 4 is 21. 5 times 5. So as we can see here, we have a bad approximation. We have a bad interval. So now what I'm going to do is I'm going to run this, except this time with -1 and 1. So -1 squared is 1, or 1 minus 4 is -3, and 1 squared is -3 as well. So it appears here that we're not having a good interval for -1 nor 1. So now let us choose -1 to be our A and 5 to be our B. So let's run this. I'm going to get x squared minus 4. Don't know the derivative. 1e to the -12. -1 for our A, B. So here we have it. We needed 0 iterations. So actually the root was exactly b plus a, b minus a divided by 2. So that's interesting. So let's actually rerun this again. -4, none, e to the -12, -1 again. Let's do it with 6. So here we have it. So to find our initial guess with the tolerance of 1e to the -4 for a bisection method, we needed 17 iterations, and then we only needed 3 iterations of our Newton's method. As we can see here, our estimated root is 2, and our value at that root is 0. So now we're going to do the exact same thing, except this time we are going to pass in the derivative. And the derivative of this function is 2x. Our tolerance is 1e to the -12 again. Our value is going to be -1 to 6. So as we can see, it worked for both knowing the derivative and not knowing it. So this just finishes up implementing our calculator within our Newton's method, and this is going to be a very powerful tool, and we're going to use it later in future videos. So stay tuned.